Let's continue the same problem. So enter the values of fixed end moments at their appropriate places. So here it is minus 62.5 plus 62.5. Then here there is no field loading, therefore 0, 0. But here there is a minus 60. See, the end A is fixed. If there is a fixed end, we have to do nothing. But DE is overhang. Therefore, here balance D, this is first step is fixed end moments. So write fixed end moments. Then balance of D and carryover. Balance of D and carryover. So unbalanced moment is minus 60, balanced is plus 60. So plus 60 into 0, here 0, here you will get plus 60, carryover same step, plus 30 by half value with same sign. Carryover same step and mark a double line because we want to take summation here to find out so this is initial fixed end moments. That means if there is a simply supported end or overhanging support, some initial adjustments are required, and once we get the initial fixed end moments, then from here onwards, as usual, we have to complete the table. So we take one summation. This is 150 as it is. Then this is plus 62.5, this is plus 30, this is plus 60, minus 60. So joint D gets balanced. Now from here onwards, do not carry over any bending moment to joint D. So now unbalanced moment, here you calculate. So plus 150 minus 62.5 means unbalanced is plus and balanced is minus. That means that minus value unbalanced moment multiplied by 0.57 you write here. That balanced moment multiplied by 0.43 you write here. And here this both are positive means unbalanced is positive, balanced is negative. And now this is already got balanced. And what are these values? So this is 49.875. 49.875. This side, this is 37.625. 37.625. And here it is 33.3. 33.3 and 59.2. 59.2. Now mark a line again. So this is called balancing. This step was balancing. Now next step, carryover. Balancing, carryover, balancing, carryover. So carryover to next support by half value with same sign. This is fixed. Now we have to carry over this. This is to be carried over to the next support by half value with same sign. This is to be carried over to the next support by half value with same sign. This is to be carried over here by half value with same sign. This is also minus. And this carryover bending moment is 24.957. Just check it. Then 16.65 and this is 18.66 and this, okay, you find out half of this and you write here. Next, balance. This is unbalanced moment. Balanced is plus plus. Is 16.65 into 0.57 you write here. 16.65 into 0.43 you write here. Similarly, this moment multiplied by 0.36 right here. This moment multiplied by 0.64 you write here. That means this is minus, so you will get here balanced moment plus plus. Unbalanced is minus, balanced distributed plus plus. Again you mark a line. So carry over this plus plus half value this plus will be carried over to here, half value but positive, half value positive. This is half value. Again, this is minus minus because unbalanced is positive. Therefore, balance this moment multiplied by 0.57 right here. This moment multiplied by 0.43 right here. Similarly, this moment multiplied by 0.36 you write here. This moment multiplied by 0.64 you write here. So this is, no, this is balanced. This cannot be carried over to this support. So this is a overhang support not to be carried over. So now this will be minus minus. Again you mark a single line. So you carry over this. So this is minus with half value. So here again you will get minus, here again you will get minus, here again, that's all. So this is carry over bending moment. Then this is minus, this is plus, 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 and okay, this is balanced. And a single line. So carry over, balance, carry over, balance, carry over, balance. And whenever you want to stop, balance and stop. And when we have to stop? Whenever the unbalanced becomes very small, that is point naught something, which will not affect on the final values of the bending moment. So whenever the unbalanced moment get vanished, becomes almost zero, or the value is in point naught something, then you stop and take the summation under each of the support. Suppose you want to stop, now balanced, and mark a double line. Mark a double line. And this one, this is called cycle. First 2, 3, 4 cycles are completed. Generally 4 to 5 cycles are sufficient to get the final answer. Now here final moments. Final moments. Say, now the final moments means you take the summation under each of the supports. You take summation under each of the supports. So you get the final moments. And this is 170.105, or almost you will get minus 171, like that. Then this is 107.97 plus 107.97 minus 107.97, 19 minus 19.3 plus 19.3, this is plus 60 minus 60. Now each and every joint support gets balanced. So here equivalent opposite, here equivalent opposite, here equivalent opposite. Okay. Now next is, once you know the bending moments, you draw BMD. So this is anti-clockwise. So 171. So this is 171 anti-clockwise, and this is clockwise, anti-clockwise. So 107.97, and this is clockwise, anti-clockwise, 19.3. This is clockwise, anti-clockwise, 60. So now we can draw BMD very easily for this problem. And for SFD, again we have to calculate reactions, and then we can draw shear force diagram also. Now only we will draw here BMD, say for bending moment diagram. So take a reference line. First, due to this loading, this is a trapezoidal diagram you will get, that you try separately, considering this as a simply supported beam, and this is 225. This ordinate you will get 225, this is 225. Then this is 90 93.75 WL square by 8, that you check it. So this is 93.75 WL square by 8, and this, due to loading, this is the BMD, due to loading. Now end moment, so you will get this upward. So this is 171, this is more than this, 93. This is 107.97, then this value is very small, 19.3, and then 60, and free end 0. So this is 60. So this is the BMD, resultant BMD is this, shown by this shaded area. So this is the bending moment diagram, BMD. And see, this is positive, this is negative over the support, this is positive, negative, positive, and negative. Due to end moment, upward, negative, due to loading, upward, positive. And these are called points of contraflexures. These are the points of contraflexures that we can look at easily. So now we have completed this third problem. Let's consider one more problem on beam. So next problem. So let's take a beam simply supported at A, B, C, D. Say here, generally this is a hinge, then this is a roller, this is again roller, and here there is a roller. But most of the time these hinge, roller, etc. are just shown by the simple supports. Now the loading, this carries UDL 12 kilonewton per meter. This also carries UDL of 12 kilonewton per meter. And here is a concentrated moment. This carries a concentrated moment of 50 kilonewton meter. And distances, this is 4 meter, this is 3 meter, 2 meter, and again this is 4 meter. So now, as usual, and here what is given, sinking of support C is given. This is A, B, C, and D. So delta C is equal to 10 mm. This is given. This is nothing but 0.010 meter. And EI, value of EI is given 2500 kilonewton meter square. Whenever sinking is given, then EI must be given. So during loading, support C sinks down by 10 mm. So this is the problem of sinking of support. Again, both the ends A and D are simply supported ends. So we are covering the varieties. Say a fixed end is there, what is to be done? Simply supported end, what is to be done? Overhanging end, what is to be done? And if moment of inertias are different, what is to be done? And if there is a sinking of support given, then how it is to be taken into account. Now here, say again the first step, fixed end moments. Now MFAB. Now as far as AB span concerned, there is no sinking, so minus WL square by 12. So substituting the values, you will get this as minus 16 kilonewton meter. Then MFBA plus WL square by 12, and this is plus 60 kilonewton meter. Now here MFBC, this is important, MFBC, because sinking of C occurs, and again this is a concentrated moment. Now left end, this moment is anti-clockwise. First you find out due to moment. Moment is anti-clockwise. So both end anti-clockwise moments will be developed. So minus, what is the formula? M into B divided by L square 2A minus B. Then now this is due to concentrated moment. Again sinking of support C occurs. C is a right support. If right support is down, both end anti-clockwise, so minus 6EI delta upon L square. 6EI delta upon L square. Means minus 15 into 2 divided by 5 square, 2 into 3 minus 2, minus 6 into 2005 into 0.01 divided by 5 square, and this you will get this as minus 10.8 kilonewton meter. Then MFCB. Now due to this, again both end anti-clockwise means this is minus, but formula is M into A divided by L square 2B minus A. Now for BC, again right support is down, means anti-clockwise, so minus both end. For BC and CB, this is minus, that is again 6 EI delta upon L square. You substitute the values, and this you will get minus 7.8 kilonewton meter. Just substitute the values and get the answer. Then the last span, MFCD equal to, now due to load, left end minus WL square by 12, and due to sinking of support, now C sinks down, means for CD, C is left. So now it develops clockwise moment, plus 6 EI delta upon L square. So you substitute the values, and the answer is minus 6.625. Minus 6.625. So you substitute values and calculate. Then MFDC equal to, this is plus WL square by 12. This is plus 6 EI delta upon L square equal to, and you will get 25.375. This is positive. So now we have calculated the fixed end moments. Now next, second step, distribution factors. Say distribution factors. First you consider joint, say B. Joint B. So KBA equal to stiffness of BA divided by stiffness of BA plus stiffness of BC. A is simply supported end or hinged support. It's 3 EI divided by 4 divided by 3 EI divided by 4 plus stiffness of BC, C is continuous, 4 EI divided by 5. And what you will get here is 0.48. This is 0.48. Therefore, KBC should be 1 minus 0.48. This is 0.52. Now next you find out for joint C. Only joint C is left. So this is for joint C. KCB D is equal to 3EI upon 4 divided by 3EI by 4 plus stiffness of CD, that is 4EI upon 5. So it is 7.48. This is also stiffness of CB, you first find out CB. For CB it is 4EI by 5 divided by, okay, this is 3EI by 4 divided by, and this is 0.52. So KCD is 1 minus 0.52, so 0.48. So now we have calculated the distribution factors as well as fixed end moments, and the next and the last step is to prepare moment distribution table. Now if there is a sinking of support, that effect is to be considered while calculating fixed end moments only. Now that's over. Now effect of sinking is now over, that we have accounted. Now next let's prepare a table as usual. Say enter the values of distribution factor over the joint B and C. Say this is 0.48, 0.52, 0.52 and 0.48. So these are the distribution factors. Now let's enter the calculated fixed end moments. This is minus 16 plus 16, then this is minus 10.8 and 7 minus 7.8, then minus 6.625, and here it is 25.375, 25.375, and this is clockwise. So this moment is clockwise. So these are called fixed end moments. Fixed end moments. Now what is the next step? Is see the ends of the B. Both the ends A and D are simply supported ends. So or this is hinge support, that is roller support, and we know that if the ends are hinge or roller or simple, bending moments must be equal to 0. So apply equal and opposite, plus 60, carry over with same sign half value. Then apply here minus 25.375, carry over with half value, same sign. So this is to be 12.687 something, 12.687. And now you will get the initial bending moments. So this is called a release of A and D and carry over. 3 steps, release of A and D and carry over. And now the initial fixed end moments. So this becomes 0, this becomes 0. Now this is plus 24, minus 10.8, minus 7.8, and this value minus 19.312. Just check it. Now next what we have to do, find out unbalanced moment at each of the joint and apply equivalent opposite as a balanced moment. That balanced moment multiplied by distribution factor, enter the values at the appropriate. Now here unbalanced is positive, so balanced is negative. Here unbalanced, so both are negative, negative means this is positive, positive. Then mark a single line, mark a single line. So these values that you find out. Now here the carryover, next by half value with same sign. Carry over next support by half value with same sign. And remember, this cannot be carried over, this cannot be carried over because A and D are simple supports. They won't take any bending moment. And again this is plus, this is minus, minus, this is minus, this is plus, this is plus. So by using distribution factors, you find out the moments here, and this is called balancing, carryover, balancing, carryover, balancing. So the number of required cycles you complete, maybe, so this is again carryover, balance, whenever you want, you balance and then stop. Carryover is this is minus, this is plus. This is plus, minus, minus balancing, this is plus, plus. Then carryover, minus, carryover, plus. And this is minus, minus, this is plus, this is plus. And then you stop. Check that the unbalanced moment should be vanished, is very low. And then you take summation under each of the support. Here it should be 0, here it should be 0. And then only under the support, see the bending moments. Say bending moment here, if you take the summation, the final bending moments are 13.59. This is plus 13.59. This is minus 13.59. And this is 3.6. Plus 3.6 minus 3.6. Now we have got the bending moments, final end moments by using moment distribution. Next you construct a BMD here. Now let's construct BMD. So we have covered all types of beam problems. So next time we will start the frames. So here, due to loading, this is 34. So this is 34, and this, you know, due to concentrated moment or simply supported, this is the diagram. And again, this is 24 UDL. Both should be actually same. It is WL square by 8. W is 12. 16 divided by 8. So it should be 24. Okay. So both the diagrams, this is 24. Now superimpose due to end moment. So this is plus means clockwise, minus means anti-clockwise. This is plus clockwise. So this is 3.6 and this is 13.59. So this is 13.59 and this is 3.6. So this is 0. This is 3.6 and 13.59. So final diagram is this. So this is your final diagram, and this small one. The shaded area represents the final BMD. So this is positive, this is negative, this is also negative. This small is positive, this is negative, this is positive. So this is BMD. This is BMD. So I think we have solved almost 4 problems of beam with various types of loadings, various types of support conditions. And next time we will see the problems on beams. So frames. So there are again 2 types of frames, sway and non-sway type frame. So how to analyze non-sway type frame, how to analyze sway type frame by using moment distribution method. So non-sway frames are again analyzed exactly to the continuous beam.